Hey guys, welcome back. In this video, we're going to cover two problems. We're going to do exercise 12-5, which looks at volume trade-off of decisions. And then we're going to look at exercise 12-6, how to manage a constrained resource. Reason why is those two topics are very similar. Well, they are similar, right? They deal with the same thing. So we're going to work on those two in this video. And the constrained resource, um, it's a little confusing. I get it. But keep in mind, we have a constrained resource and we need to figure out what's the most profitable way we could use this constrained resource, right? Well, in order to determine that, we have to look at the contribution margin from each product per that constrained resource. Okay, so let's go ahead and do that. Exercise 12-5 deals with a company that makes high-end hard-sided luggage for sports equipment. And they give us data for ski guards, golf guards, and fish guards. They give us the selling price, the variable cost. They tell us the amount of time that is required to make each of those products. And they also tell us the amount of plastic pellets that is required to make each of those products. So the first thing the problem asks us to do is to assume that the total time available on plastic injection molding machines is a constraint. So it's the time that is the constraint, not the supply, it's the time. So we got to figure out first how much contribution per minute of the constrained resource is earned by each product. Very simple, right? Back in chapter 5 CVP analysis, we know what the contribution margin is. We know how to get that. So we're going to first put in our selling price. I'm just going to abbreviate it SP. And the selling price for the ski guard's $200. For the golf guard, it's $300, and for the fishing guard, it's $255. So if we looked at this based solely on the sales revenue, we would say, hey, the golf guard's the way to go. But remember, we have to factor in cost, the variable cost, and the fixed costs. So the next thing we're going to do is subtract out variable costs so we can get that contribution margin, because we know that's really where we need to be, right? The contribution margin. So the variable cost for the ski guard is $60. The variable cost for the golf guard is $140, and the variable cost for the fishing guard is $55. So now we could calculate that contribution margin. Well, for ski guards, we get $140. For the golf guard, we get $160. And for the fishing guard, we get $200. Now, just by looking at this, you would say, hey, you know what? Based on contribution margin solely, look at the fishing guard contribution margin. It's $200. Well, I should make that one. Well, we have to remember, take the contribution margin in relation to the constrained resource. So in part one, the constrained resource is the molding machine time. So I'm just going to say processing time. And for the ski guard, it's 2 minutes. For the golf guard, it's 5 minutes. And for the fishing guard, it's 4 minutes. Now, I look at the contribution margin per unit of the constrained resource. So I'm just going to say CM per unit of constrained resource. Okay, so I'm basically just going to divide my contribution margin by the time. So just for, I'm going to say contribution margin is A, processing is B, and I'm just going to divide A by B. Divided by B. Okay, so that's how I calculate it. So I see then, based on the contribution margin per unit of constrained resource, 140 divided by 2, I see I get $70 per minute. For Golf Guard, I get $32 per minute. And for Fishing Guard, I get $50 per minute. Okay, so based on this, based on the fact that Ski Guard gets the second highest sales revenue, it has the least highest contribution margin, but based on processing time, because we can pump out those Ski Guards the quickest, we get $70 per minute, or $70 contribution margin per minute of the constrained resource. So in this case, the answer to number 2, which asks us which product offers the most profitable use of plastic injection molding, well, it's the Ski Guard, right? That is the most profitable use of the constrained resource. Okay, however, in this case, we're dealing with the constrained resource as the machine time, right? The contribution margin per minute is $70 for the product, and that's the largest out of that's the largest out of Golf Guards and Fishing Guards. Now 3 says, let's assume that there is a severe shortage in plastic pellets. Okay, so we have to cut back on our production. So the new constraint now has become the total available pounds of plastic pellets. We're getting away from processing time now. Now we're just focusing in on the plastic pellets. Okay, so based solely on the plastic pellets, how much contribution margin per pound of the constrained resource is earned by each product. So we're going to do the same exact thing, but instead of processing time being our constraint, it's going to be plastic pellets. So we're going to do the same exact thing, right? What's the selling price? For guards, or Ski Guards, 200. For Golf Guards, 300. For Fishing Guards, 255. Nothing changed, right? Same thing for variable cost. Variable costs are still the same. 60 for Ski Guards, 140 for Golf Guards, and 55 for Fishing Guards. CM still the same, did not change, right? It's $140 CM for the Ski Guard. For the Golf Guard, it's $160 of contribution margin, and the Fishing Guard provides $200 of contribution margin. So that's our A column, right? Now we got to factor in the constrained resource. So what is the constrained resource? It's the plastic pellets, specifically pounds of plastic pellets. Well, we can see here that Ski Guards require 7 pounds of plastic pellets. Golf Guards require 4, and Fishing Guards require 8. So now we got to figure out what's the CM per constrained resource, or we're going to say A divided by B, And we see now that the ski guard actually only gives us $20 per pound. The golf guard gives us $40 per pound. Excuse me. And the fishing guard gives us $25 per pound. Okay. So to answer number 4, it says, which product offers the most profitable use of plastic pellets? Well, in this case, guess what? It's the golf guard, because the golf guard gives us the most profitable use of the constraint by giving us $40 per pound. Okay, and this is larger than ski guard and the fishing guard. So number 5 says, or 5 asks, which product has the largest contribution margin per unit? Why wouldn't this be the most profitable use of the constrained resource in either case? Well, if we look at it, we look at the contribution margin, we see that fishing guard gives us the largest unit contribution margin, right? But it's not the most profitable use of the constrained resource in either of the cases. Why does this happen? Well, because the fishing guard uses more of the constrained resource in proportion to its contribution margin than the other two products. So basically what we're saying here is more of the other products can be produced for a given amount of the constrained resource, and this more than makes up for the lower contribution margin. I'll say that again because that's pretty important, right? What we're basically saying here is that the other two products are going to be produced more given the amount of the constrained resource, because that addition that we get makes up for their lower contribution margin. So for golf guards, we can pump out more golf guards by using less plastic pellets. In 12A, we could pump out more ski guards because it required less time than the other two products. Okay, so that's exercise 12-5. Now, exercise 12-6 deals with managing a constrained resource, right? And we have a resource that's constrained, and we have to choose, what do we produce, what demand do we fill, right? So here we have a company that apparently, again, it's just like the example we did in the lecture video, Fine Colonial Reproduction Furniture, right? They do upholstered furniture is one of the major product lines, and upholstered furniture is actually the bottleneck on this production line, based on the time in the upholstery shop. So they tell us that upholstering is a craft that takes years of experience to master, and the demand for upholstered furniture far exceeds the company's capacity in the upholstering shop. They give us information about 3 upholstered chairs, a recliner, a sofa, and a love seat. They give us the variable costs, and they give us the time required to produce each unit. Okay? So the first thing that we're going to do is we're going to figure out the value of relaxing the constraint resource, right? How do we determine that? Well, in order to determine that, we have to compute the CM per unit of the constrained resource, right? Just like we did before, okay? So, let's look at number 1, right? Number one says more time could be made available in the upholstery shop by asking the employees who work in this shop to work overtime. Assuming, excuse me, assuming that this extra time would be used to produce sofas, up to how much of a premium should the company be willing to pay in terms of an overtime premium per hour to keep the upholstery shop open after normal work hours? So in order to figure this out, we have to figure out, okay, what's the amount of the constrained resource? So we're dealing with sofas here. So I'm going to put a sofa there. And we know that the selling price is $1,800. Oh, sorry. Selling P is $1,800. We know that the variable cost is $1,200. So we know that the contribution margin is $600. Okay, so now what is the constrained resource? Well, it's the time required to produce one unit. So time required, and the chart tells us that it takes 10 hours to make a sofa. So we're going to divide CM by the time required, and we end up with $60. So the company would be willing to pay an overtime premium of up to $60 per hour to keep the upholstery shop open after normal hours. 2 says, or question 2 says, a small nearby upholstery shop has offered up upholstered furniture for Portsmouth at a fixed charge of $45 per hour. So basically, we have another upholstery shop saying, "Hey, we'll do your work for you. We'll upholster these love seats for you. But we're going to charge you $45 per hour." How much of an additional contribution margin per hour can Portsmouth earn if it hires a nearby upholstery company to make its love seats? So in B, we're looking strictly at love seats. And we need to calculate, okay, what are we willing to pay, right? What's the additional contribution margin per hour earned by hiring the nearby company, right? So that's easy for us to do. First thing we're going to do, figure out what's our selling price. Well, we don't have to figure anything out because they tell us. Selling price is, for the love seat, is $1,500. The variable cost for the love seat is $1,000. That means we have a contribution margin of $500. How long does it take us to make one unit or one love seat? Well, it takes 5 hours. So we'll say the time required to make the love seat is 5 hours. So that means then that the CM per unit is 500 divided by 5. That's $100 per hour. Okay, but the question asks us, what's the additional contribution margin per hour earned by having the nearby company do our upholstering, right? So we're basically paying out $45. So if we take 100 minus $45, we see that our contribution margin per hour is now $55 because we're paying them to do more work for us. Okay? 3 asks, should Portsmouth hire the nearby upholstering company? Explain. Um, Basically, for $45 per hour, they should accept the offer, right? Why? Well, because the time would be used to upholster love seats. If this increases the total production and sales of love seats, the time would be worth $100 per hour, or a net gain of $55 per hour if love seats are already being produced up to demand. So what happens is they have these units upholstered by the other company. It free ups capacity in Plymouth's company to produce more of the other two product lines, right? In this case, the additional $45 per hour is well worth the time. Okay, so that's how we handle not special orders, I'm sorry, constrained resource and managing a constrained resource. When we come back, we're going to look at a process further or sell as is decision. So please tune back in for that one.